My name is Flash Isaac, and I'm a teacher from the future. Hello, you are welcome to episode number 86 of the 120 Days to Jamb Physics with Flash Isaac. In this episode, I shall be saying bye-bye to DC circuits generally. I told you that current is the flow of charges in a circuit. And current electricity is different from static electricity in the sense that static electricities are charges built up on the surface of substances, materials. Static electricity or electrostatics can develop in either conductors or insulators. Meanwhile, current, on the other hand, only flows in conductors. Conductors are devices that allow the flow of current. This is because they have lower resistance. And we discuss Ohm's Law, which says that an electric current passing through a metallic conductor. So Ohm's Law only holds for metals or metallic conductors. It does not hold for every other type of materials, which is a limitation of Ohm's Law. So the current that will flow through a material or a metallic conductor is proportional to the potential difference, that is voltage at its ends. So the summary of Ohm's law is that voltage is proportional to current and V is equals IR or ROI. The resistor or resistance is the constant. And what is resistance? It is the opposition to the flow of current. Now, this is the straight Ohm's law. Ohm's law can be reversed to give us something like this. Current is proportional to voltage. If you are making current the subject formula in Ohm's law, you are reversing it because current becomes a constant times voltage instead of voltage becoming a constant times current. In this case, the value of this constant will not be resistance. It will be inverse of resistance. And what is the inverse of resistance? It is simply conductance or conductivity or conductance. Current electricity can either be DC or AC. DC stands for direct current. Direct current, they flow only in one direction. They do not change direction and they have polarity, positive and negative. Alternating currents are a type of current that change the direction of flow. They flow in positive half, negative half, positive half, and negative half. The current you use in your house for your TV, for your lights, they are alternating currents. If you look at your electric bulbs very well through a, let's say, a microscope or powerful devices, you notice that this is how your bulb is doing. Turns on, turns off, turns on, turns off, turns on, turns off. Even your TV goes on, off, goes on, off, because the current is alternating. But you can't see that with your naked eye, and it's also happening very, very fast, so your eyes cannot see it. And even in terms of current, when you on your switch, the current has to flow from that switch to your bulb for the bulb to light up. But because it happens very fast, you definitely think immediately you turn on your switch, the light comes up. So all these are interesting. And one major difference or another major difference between DC circuits, direct current, and alternating current circuit is that for a direct current circuit, you notice that we'll be finding only resistors. Find the resistance, find the current. Resistors are the only device that oppose the flow of current when it comes to DC circuit. But for AC circuit, you begin to see both resistors, capacitors, and inductors. So these guys, only three of them will be opposing the flow of current in one device. So for a circuit where capacitors, inductors, and resistors are opposing the flow of current, or we call those ones RLC circuits. R for resistance or resistor, L for inductor, C for capacitor. Resistor opposing the flow of current, we call that resistance. Opposition to the flow of current offered by capacitors and inductors, we call them reactance. For capacitors, capacitive reactance. For inductors, inductive reactance. And you see a resonance in circuit. The good news is that capacitors have been treated, alternating current circuit, AC circuits have been treated. So we are doing so well so far, and we have to look at this question right now. In the circuit above, 3 resistors, 2 ohms, 4 ohms, and 12 ohms are connected in parallel. 3 resistors, 2 ohms, we have 4 ohms, 12 ohms are connected in parallel, as we can already see. And these guys are connected to a 12 volts battery. 12 volts. So the voltage or the EMF is equals 12 volts. What do we do? In parallel, 1 over the equivalent resistance is 1 over 2 plus 1 over 4 plus 1 over 12. 1 over R equivalent is equals LCM is 12. 12 divided by 2, that should give us 6. 6 times 1 is 6 plus 12 divided by 4, that should give us 3. 3 times 1 is 3 plus 12 divided by 12 is 1. 1 times 1 is 1. So 1 over the resistance equivalent or total is 6, 7, 8, 10 over 12, and that is 5 over 6. So 1 over equivalent resistance is 5 over 6. Equivalent resistance would therefore be 6 over 5. So the resistance in the circuit is 6 over 5. So the current flowing through the 12 ohm resistor is different from the one flowing through the 4 ohms, and it is different from the one flowing through the 2 ohms, because for parallel arrangement, the same voltage flow, different current is actually flowing. If you've been able to solve and arrive at this value of equivalent resistance, you are correct. But the truth is, do we need to find the equivalent resistance? No, we don't need. If we are asked to look for the current flowing, it will be this will be correct. From the equivalent resistance, we will find the current, because different current flows through resistors in parallel. But in this case, the resistors are in parallel. The same voltage will flow. So 12 volts is what is flowing through the 2 ohms. 12 volts is what is flowing through the 4 ohms. 12 volts is what is flowing through the 12 ohms resistor. So this is not even needed at all. So what do? The same voltage is flowing. So V is equals I arrow. The current will simply be, for the 12 ohms, 12 over resistance, that's 1 amp. The current flowing across the 4 ohms resistor will be 12 volts over 4 ohms. The current flowing across the 2 ohms resistor is 12 volts over 2 ohms. Ladies and gentlemen, once again, I say when you see this type of question, which says, in the circuit above, 3 resistors, 2 ohms, 4 ohms, and 12 ohms are connected in parallel, and a 12 volt battery disconnected across the combination. The current flowing through the 12 ohm resistor is dash. The first thing that would have come to your mind will be to look for the equivalent resistance. Then you look for current by saying V is equals I arrow. But from here, current is voltage over resistance. Now the voltage is not changing. The voltage is not changing. Therefore, the current across the 12 ohm resistor will be the voltage over the resistance, 12 ohms. The current across the 2 ohms resistor will be the voltage over the resistance. The current in the 4 ohm resistor will be 12 over 4. This is your answer. But if you were asked to look for the current that flows in the circuit or the equivalent current, as such, you can find the equivalent resistance and solve. But we are looking for current across each of the resistor and they are in parallel. This is how you go about it. I don't know if I confused you or I understood you. In fact, that is the reason I solved only this question, to make it clear to you. And look at the other ones I've solved since, and see the similarities and see something to take out of it. See you in the next episode.